27.3 is solving contextual problems, and contextual problems just mean like real life situations. So one situation that can be represented really well by quadratics is a projectile, which is something that's like thrown or launched into the air. Because quadratics, they're graphs, they're parabolas, so I can picture like a graph shooting up and shooting down like this, and that's like the same path that an object shot through the air would take or thrown through the air would take. So that's why we're able to use quadratics to represent these situations. So the formula for projectile is actually 2, depending on what unit of measurement the problem has. So on the left, you can see in meters, the formula is h equals negative 5t squared plus v with that little 0 t plus h with that little 0. So those little zeros are subscripts. And when you see subscripts with a 0, that means like a starting value or an initial value. So you'll see over here, the v with the subscript of 0 is the starting velocity. H with the subscript of 0 is the starting height. So from here on out, when I read those in the equation, like the v with the subscript of 0, I will be shortening it and I'll say v and then sub for subscript 0. And then this would be read as h and then sub 0 instead of like kind of reading out the whole thing. So I'm going to read through this formula one more time. It's h equals negative 5t squared plus v sub 0 t plus h sub 0. And then the other formula is for when it's in feet. And it's h equals negative 16t squared plus v sub 0 t plus h sub 0. So you'll see like the only difference between those two formulas is this has a negative 5 in front and this has a negative 16 in front. And those values are actually kind of the gravitational pull that an object has as it's kind of coming back down through the ground. So meters, there's like a little bit more than 3 feet in a meter. So that kind of makes sense. Like if we take the negative 5 that's from the meter formula and multiply it by a little bit more than by 3, we would get negative 16. So it's just kind of like converting between feet and meters, but the rest of the formula stays the same. Okay, so example 1. A ball is thrown straight up from 2 meters above the ground with a starting velocity of 12 meters per second. When does it reach the ground? So before we can set up our equation, we have to decide what formula we need to use. This is a ball being thrown upward, thrown through the air, so we can use the projectile formula, but we have to look at what is the unit of measurement. And it says that the ball is thrown straight up from 2 meters above the ground, and the velocity is 12 meters per second. So it's definitely in meters, so we're going to use the meter formula. So I'm going to copy it down right here. So h equals negative 5 t squared and then plus v sub t plus h I said v sub t, I think. Sorry. Okay, so I'm going to fix it. Plus v sub 0 t and then plus h sub 0. And then when you are using this formula, we have to put something in for that v sub 0, the starting velocity, and the h sub 0, the starting height. So we find those values from the problem itself. So if we read back through the problem one more time, it says a ball is being thrown straight up from 2 meters above the ground. So that 2 meters above the ground, that's where it's starting. So that's the initial height. That'll go in for h sub 0. And then it says with a starting velocity of 12 meters per second. So it says starting velocity right in there. So that's going to be our v sub 0, and that'll go in right here. And then that's all we're going to put into the equation for now. So h equals negative 5 t squared plus v sub 0 is going to be 12 because the starting velocity was 12 meters per second, t. And then plus h sub 0, that was 2 because the starting height was 2. So we put 12 in for v sub 0, but there's still that t there. That's going to stay there. It's kind of like x in this case. We just use t for time instead of x. And then h sub 0 gets replaced with the 2. And then now we have an equation that represents this situation. So if I were to take this and put it into like a graphing calculator or graph it myself, it would show me the path of the ball as it's thrown up into the air and as it comes back down. So now we have to figure out what is the question asking us to actually find. It says when does it reach the ground? Like when does the ball reach the ground? So it's asking us to solve for a time because it says when, and when's like what time, and then the time for like a specific height. So in this case, it's when the ball reaches the ground. So we have to think, what is the ground's height? The ground's height is 0. It's on the ground. So we would put 0 in for just the regular h. That regular h is going to be like whatever height you're asked to, not like find in the problem, but like in this case, we're asked to find how long it takes before it reaches the ground. If like, for example, it said how long does it take before it reaches a height of like 10 meters, we would put 10 in for h. So whatever kind of specific height you're given in the problem, you would put into h. So this is going to be 0 because it's the ground, and then is equal to negative 5t squared plus 12t plus 2. And then now I have an equation, it's in standard form, and I'm trying to solve for t because it says when does it reach the ground. So I put the proper height in there, and now I just have to figure out what t makes this work. I have to solve for t, so to do that I can use the quadratic formula. So I'm going to copy down the quadratic formula really quick. Usually it's x equals, but in this case we have t's instead of x's, so I'll use t equals negative b plus or minus the square root of b squared minus 4ac, and then all over to a. And then same rules here apply like when we're finding a, b, and c. So a is the coefficient of x squared usually, but in this case we have t's, so a would be the coefficient of t squared, which is negative 5. And then b is the coefficient of t, so b would be 12, and then c is the constant, which is 2. So we would put negative 5 in for both of the a's, and then we'd put 12 in for both of the b's, and then we'd put 2 in for c. So negative b goes first, so it'll be negative 12, and then plus or minus the square root of b squared, so it'll be 12 squared, and then minus 4 times a, and a is negative 5, so times negative 5, times c, which is 2. And then that's all over to a, so 2 times negative 5. And then we'll start to simplify the inside of the radical. So I'll just bring over the negative 12 first to start, and then plus or minus the square root of inside the radical. 12 squared means 12 times 12, so that's 144. And then for my like minus 4 times negative 5 times 2, I'm going to count my negatives just like I did in like kind of the non-word problem versions of these. So I have 1, 2 negatives, which is an even amount. So an even amount of negatives would give me a positive product, so I'll put my plus sign. And then now I don't have to worry about the signs. So 4 times 5 is 20, and then 20 times 2 is 40. So this will be a plus 40. And then over 2 times 5, or 2 times negative 5 in the denominator is negative 10. And then now I can add inside the radical. So I have negative 12, and then plus or minus the square root of 144 plus 40 is 184. And then over negative 10. And then most of the time, if not all the time, when you have a word problem, especially when you're like solving for time, you kind of want to treat it like as if somebody's walking down the street and asks you how long before the ball hits the ground. And if you told them this answer, if you're like, oh, negative 12 plus or minus the square root of 184, which is negative 10, they would look at you like you're crazy. So most of the time with word problems, we want to get a decimal approximation because it's just like a little bit easier to digest. So that's what we're going to do. Okay, so just have the Google calculator up here. So once I have it kind of set up and I want to find the square root of 184, I click on the radical, which is that like kind of funky check mark. It's in the third row the fourth row, and then the third button over. And then I type in 184 and get that. And it's a decimal, of course, but we're just going to round to 2 decimal places, and it's just an approximation, but it's going to be close enough to give like a reasonable answer. So whenever we approximate, we usually change to like the squiggly equals, and that means approximately. So negative 12, and then plus or minus. So it's 13.56. So if we want to round to 2 decimal places, we'll look at the third number, and the third number is a 4. So, or sorry, the third number after the decimal place, and the third number is a 4. So I don't need to round the 6 up or anything. I only round for 5 or above. So negative 12 plus or minus 13.56 over 10. And then now that I have a number that doesn't have a radical, I can go ahead and I can create my two different equations and get both of my answers. So I'll say t is approximately negative 12, and then plus 1 is going to be a plus 13.56 over 10, over negative 10, sorry. And then 1 is going to be a t is approximately negative 12 minus 13.56 over negative 10. So everything in the problem stayed exactly the same. It's just 1 had a plus and then 1 had a minus is the only change. I'm going to scooch both these over just so I have a little bit of room to like write the final answer on each. So I'll line them up over here. And then I'll simplify the one on the left first. So negative 12 plus 13.56. So I'll click the minus first for the negative 12. Oops, gotta clear the 0 off. So negative 12 and then plus 13.56 is 1.56. And then I need to divide that by negative 10. And that's negative 0.156. I'm going to round it to 2 decimal places just to keep it consistent. So about negative 0.1, and then the 6 will round the 5 up to a 6. So it'd be negative 0.16. And then for the second one, it's negative 12 minus 13.56. So negative 12 minus 13.56 is negative 25.56, and then if we divide that by negative 10, it's 2.556, and again, I'm going to round it to 2 decimal places here as well, so 2.56, because that 6 would round the 5 up to a 6, so 2.56. And then now, of course, like we have 2 answers, and we have to kind of figure out which one makes more sense in the context of this problem. So the question itself was asking, when does it reach the ground, or like how long does it take for the ball to reach the ground? So since we're solving for t or time, it doesn't make sense to have a negative time. So that negative 0.16, we didn't do anything wrong to get that. It's just called an extraneous solution, meaning it's like not valid for this problem. And then the equation, or sorry, the solution that we use is the 2.56. So we would say, we would say, my pen was really small. We would say it takes about 2.5 seconds before the ball reaches the ground. So a ball reaches the ground in about 2.56 seconds. Okay, so example 2, what is the maximum height of the ball from example 1? So since it's asking about the same exact situation, we're going to use the same exact equation. So I'm just going to go ahead and copy down the equation that we set up for example 1 because it represents the same situation, so same setup. And then for this one, it says what is the maximum height, and up until this point we have found the maximum height of just like vertex form equations by like finding what the vertex is and finding the y-coordinate, and we're going to find the vertex here as well, but we just kind of have to approach a little bit differently because this equation is in standard form. So for this, the process is going to be, the first step would be to find x equals negative b over 2a. That's the formula for the line of symmetry of any parabola. It's usually x equals negative b over 2a, but in this equation we use t's, so I'm just going to swap out x for t, but in general it would be x equals negative b over 2a. And then once we find that number, we put that number in for t in the equation. Okay, so step 1, find negative b over 2a, that's the line of symmetry, and then we put that number in for t into the equation. That'll give us the maximum height. So we'll figure out what A, B, and C are. It's the same thing as like the first problem, example 1. Really, we just need A and B for this one. So A is still -5, and then B is still +12. So our formula is T equals -B over 2A. So we'll put B, or 12 in for B, and then -5 in for A, and simplify. So -B would become -12 over 2 times -5 for A, and then I can multiply 2 times -5, that's -10, and then -12 in the numerator, and that means -12 divided by -10, which is a +1.2. So that, like, T equals 1.2, that's the time it takes before the ball reaches its max height. And then to find the actual max height, we have to take that 1.2 and put it into the equation where T is. So I'm going to shrink this down a bit just so I have some more space. And then we're going to take that 1.2 and put it in the equation for both T's. So 1.2 will go right here, and then we can simplify. So H equals -5 times 1.2 squared plus 12 times 1.2 plus 2. So 1.2 replaced or swapped out for both the T's. And then now I follow order of operations to simplify. So first I'm going to go ahead and square the 1.2. So it'd be H equals -5, and then 1.2 squared is 1.44. And then plus 12 times 1.2 plus 2, and then next I'm going to simplify the multiplication, so I'll multiply both of those. So H equals -5 times 1.44 is -7.2, and then 12 times 1.2 is +14.4, and then plus 2, and now I can add everything together from left to right. So I would do -7.2, and then plus 14.4, and then plus 2, and you should end up with 9.2. So we ended up with H equals 9.2 after putting in that 1.2 in. So this is like over here, this is the 1.2. This is the time when it reaches its max height. And then the actual max height is 9.2, excuse me. So the first part, the -b over 2a, that gives you the time it reaches its max height. And then once we find that number, we put it into the equation to find the actual max height. And in this case, it's in meters. So I'm just going to write the final answer as 9.2 meters. Okay, so before we move on to example 3, this part right here is something that's like kind of really nice to save. It's just instructions on how to find the max height in standard form. I'm going to throw the title above that. So max height in standard form. Okay, so example 3. Joe has a rectangular chicken coop. The length of the coop is 4 feet less than twice the width. The area of the chicken coop is 510 square feet. Write an equation that represents this situation. So we're given the area of this rectangular chicken coop. So our equation has to be kind of based around the area formula, which is length times width equals area. And we're given that the area is 510 square feet, so we can put that in for A, but we have to figure out what to put in for length and width. So up here it says that the length of the coop is 4 feet less than twice the width. So the length is written in terms of the width. So we could use X to represent just the width, and then we can write the length in terms of X. So it says 4 feet less than twice the width. So twice the width would be 2 times X. And then 4 less than that would be minus 4. So 2x minus 4 is going to be the length. And then in the formula itself, it has like length times width. I think it's a little bit easier when we put like just the single variable before the binomial when we write our equation, just when we go to simplify it. So I'm going to put like width times length. And remember, we can always like reorder factors anytime we're multiplying. So I'm going to write it as width times length, and that's just so I can put the x first. So width x, and then times length 2x minus 4, and then that's going to be equal to the area, which was that 510 square feet. And then I meant to write this into the instructions. I'll get it added by the time you can like print it, but I want the equation to be in standard form. So if I want to get this equation in standard form, that means that it's simplified and everything is on one side of the equal sign. So first I need to distribute. So I would do x times 2x, that's 2x squared. And x times negative 4 is negative 4x equals 510. And then I need everything on one side of the equal sign, so I have to cancel out that 510. Because it's positive, I'm going to subtract it over to cancel it out on the right side. And then I don't have any constant terms on the left side of my equal sign, so I'm just going to subtract the 510 after the negative 4x. It's just going to kind of go in line with it. So I'll bring down the 2x squared minus 4x and then minus 510 after that. And then equals right here, 510 minus 510 is 0, so that cancels out. And then now I have everything on one side, the other side is 0, so that's one part of standard form. And then the second part is that it goes in order from like x squared down to x down to the constant. So 2x squared is first, and then negative 4x is second, and then the constant is third on that side. So we're all good, it's in standard form, and then it doesn't ask to solve, we just needed to write the equation itself, so we'll leave it as is. 2x squared minus 4x minus 510 is equal to 0.